Whereas olfaction assesses the sensory contributions of volatile wine components, taste evaluates the non-volatile constituents responsible for the sweetness, sourness, saltiness and bitterness of wine, as well as the tactile sensations such as body, astringency and warmth. The primary taste organ is the tongue. The tongue is covered in raised areas called papillae, which contain our taste buds. Additional taste buds can also be found in the roof of the mouth and on the epiglottis and esophagus. Receptor cells within each taste bud are responsible for detecting the presence of taste substances and sensations. These interactions cause electrical activity which is subsequently transmitted to the brain for processing in a manner similar to that of the olfactory system. The main wine components responsible for the basic tastes of wine are sugars and to a lesser extent ethanol for sweetness, acids for sourness, phenolic compounds for bitterness and salts of minerals or acids for saltiness, although it's rare for a wine to be perceived as salty. Many of these substances also elicit tactile sensations. As indicated earlier, the body and palate weight of a wine are closely associated with its alcohol content, but alcohol can also produce warmth and sweetness on the palate. Viscosity and therefore body are also influenced by the concentration of sugar. Phenolic compounds are responsible for the drying, puckering sensation known as astringency. These tactile sensations are the result of chemical interactions between tannins, a subclass of phenolic compounds, and protein in our saliva. This process strips the mouth of saliva, and the increased friction that results is perceived by touch receptors located throughout the mouth. Some tannins are smooth and velvety, but some are coarse and rough. These tactile sensations contribute to the overall mouthfeel of a wine. In some instances, the presence of gases such as carbon dioxide or sulfur dioxide can also stimulate tactile sensations. Tingling or spritz in the case of carbon dioxide and irritation in the throat in the case of sulfur dioxide. Individually, the taste and tactile sensations associated with different non-volatile wine components are readily discerned, but collectively our perception of one component will be affected by our perception of others. As with olfaction, the principal interaction between taste components is that of suppression. Therefore, an important winemaking skill is the ability to achieve a balance in a wine. For example, the mutual suppression of wine acidity and sweetness to achieve a wine that is crisp, not sour, or sweet, but not sickly sweet. Taste sensations can also enhance tactile sensations. Increased acidity has been shown to heighten our perception of astringency, while increased ethanol can enhance not only bitterness, but also the warmth of wine. The ability to discern different tastes is an objective sensory exercise and can be learned with some practice.